Welcome to Study Loop.
Hey, it's Clarissa and Numeraid here. So for part A, it states that the sum of two negative integers is negative. So we're going to let the domain be all integers, and we know that it's negative if it's less than 0. So if we write this is for all integers x and integers y. If x is negative and y is negative, then when you add them up, they're both going to be negative. Their sum is going to be negative. So we can write it as this. And y is less than 0, then their sum is negative. For part B, we have the difference of two positive integers is not necessarily positive. So we know that something's positive when it's larger than 0. So a value is positive when it is smaller than or equal to 0. When it's larger than or equal to 0, excuse me. So we can rewrite it as there is an integer x and y such that y and x are positive and their difference is not positive. So existential for x and y, they're both larger than 0 since they're positive. Then their difference is less than or equal to 0 since the difference of two positive integers is not necessarily positive. For part C, it says the sum of the squares of two integers is greater than or equal to the square of their sum. So for C, it can be rewritten as for all integers x and y, the sum of the squares of x and y is greater than or equal to the square of the sum of x and y. So we use our universal for x and y, and we add their squares, which is bigger or equal to x plus y square. Finally, for D, it states the absolute value of the product of two integers is the product of their absolute values. Excuse me. And this can be rewritten as for all integers x and y, the absolute value of the product of x and y is when you multiply the absolute value of x and the absolute value of y. So we have our universal quantification. The absolute value of x, y is equivalent to the absolute value of x multiplied by the absolute value of y.